Hey guys, I'm here with Adrienne, and we will be talking about traits in reproduction.
Specifically, the reason why each member of the Darwin bark spiders have different traits for silk.
Let's get it.
We are going to pretty much break down our understanding and our conclusion that why members of the Darwin bark spider have different traits for silk flexibility. So, Adrienne, you can take it away.
All right. So the reason each Darwin bark spider may have different traits for silk flexibility may be due to the cause of gene variation, where each spider has a variation of each of their parents' genes. For example, if we were to breed Greg and Zora, most of their offsprings will have F1, 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 F2, or F1, F3.
So let's do that now. Who's the two people you wanted to do?
Greg and Zora.
All right, so if I was to use this simulation on Amplify, and let's see, move Greg to Zora, and I will focus on silk flexibility. What are some things I noticed about her gene version, or his gene version?
Greg has homozygous for F1, which is the gene version for low silk flexibility or medium.
And what about Zora?
Zora has high silk flexibility due to the gene F3 being the dominant one and F2 just being the recessive gene, which can also be shown in their offspring.
So let's see what their offsprings, what type of traits and gene versions or gene combinations they come up with. So let's create. And let's randomly fertilize. Okay, so we got 4 offsprings, and what have we noticed?
3 out of the 4 offsprings have F1, F3, which the F1 gene is dominant in all of them, except for Spider 4, which has gotten its mother's gene of F1, of F2, and its father's gene of F1. So F2 in Spider 4 is the dominant trait, while F1 is the repetitive. F1 is the trait for low silk flexibility, F2 is the trait for medium. So Spider 4 has the trait for medium silk flexibility instead of having low silk flexibility like all of its siblings due to gene variation and its different gene combination.
Yeah, because it didn't get the same combination as their siblings. Spider 4 got a different combination. Although all of the spiders got the genes from their parents, one from each. Because of the variation of combination, they were able to have different traits as well. All right, so I guess this kind of proves your point of what you were saying.
This proves that Claim 1 is the reason why each member of the Darwin bark spiders have different traits, because a mutation in the genes usually changes the genes of a spider or an organism to have traits that its parents didn't have. So, for example, if your parents have the proteins or the gene variation of F1 and your mother has the gene variation of F2, if you end up having F3, you have a mutation in your genes.
Yeah, that makes sense. And in this case, this didn't happen. So we know for a fact that it wasn't due to mutation. It was simply just due to a variety of gene combination and gene versions. All right, good job. Thanks.